So in question number 3, let's try to be a bit more purposeful. Now that we know that these expressions are telling us an initial value, a multiplier, and a specific term number to refer to, let's see if we can try to be a bit more deliberate about setting up our sequence so that we don't have to do a whole bunch of extra work. We can go straight to what we need. I'm going to end up making a series of tables here, much like you saw me do in questions 1 and 2, but I'm not going to make the whole table. I'm just going to make the part of the table that I need to answer the question. So if you need some scratch space, you might want to find some. You see I just kind of been using a random piece of scratch paper here. Let's see if we can do this with a bit more purpose. Whenever we're looking at an expression such as these, anything that looks geometric, we know we can identify three things right off the bat. The number at the beginning of the expression, the number that is not directly attached to the exponent, is the initial value. We know that for sure. So in this case where it says initial, I know that they're referring to the 20. The number in the parentheses, or the number that is directly attached to the exponent, the number that serves as the base of the exponent, that's the multiplier. So I know in this context, the multiplier must be the 1/2. Now in a table, that means if I have my little table of x and f of x, the initial value is always the 0 term. And you'll notice I'm switching to x equals 0 instead of n equals 0. It doesn't matter what letter you use, it's all the same thing. So the 0 term in the table is definitely the initial value, that is 20. The multiplier will be 1/2. So if I need to travel to other terms, I know that I'm going to have to multiply 1/2 to go forwards in the sequence. That also tips me off that if I want to go backwards in the sequence, I'll do the opposite, which would be multiply by 2. But we'll see if we need that. Now, the last part of the expression is the exponent. And the exponent is really just the term number that they want us to focus on. So the exponent is really just saying, hey, go to the 0 term in the table. Well, great news for us. The 0 term in the table, term number 0, is the 20. We already know that. So the value of this expression is 20. That's it. That's all I wanted us to do. So that's the nice part about being able to parse this whole thing, is saying to ourselves, hey, if we know that the initial value is the 0 term and they're asking us for the 0 term, why would we do any work? We would just look at that and go, oh, 0 term, 20, boom, done. If you've gotten to the point where you don't even have to write a table because you can do this just in your head, you know exactly which term it's talking about, that's awesome, just do that. But I'll do a bit of color coding here so you can tell. The term number is the exponent, hence the yellow. The multiplier is the thing inside the parentheses, hence the pink. And the initial value is the term outside of the parentheses at the beginning, hence the green. So hopefully that gives you a little bit of structure that you can apply to the next questions. For example, if you look at letter B and tell yourself, oh, Herbert, it's a typo. It's the exact same thing. 1/2 and the 20, it's 0. It's the same problem. What are you doing? This is crazy. Look at it carefully, though, because there is something a little different about letter B, and we should notice the placement of things. Remember how the initial value is the number that's at the beginning, before the parentheses, and not attached to the exponent? Notice what's there now. This time the initial value is 1/2. And this time the multiplier in the parentheses is the 20. So paying attention to the structure is really the important part. The numbers themselves are not as important. The structure is, because the structure is what dictates the job of that number in the sequence. The exponent is still the term number. So in this case, they're still asking us for the 0 term. But let's think about what that table would look like. That if I had my x and f of x table, the initial value, x of 0, would be 1/2. And the multiplier would be 20. So like 1/2 times 20 would give me the next term in the sequence and so on. Now it does clarify that I just need the 0 term. This question specified that I only needed to report the 0 term. The 0 term in this table is, of course, the 1/2. But notice that's a different answer than I got for letter B. So the placement of the numbers is so critical, and that's actually the point of this exercise, is to get you paying attention not just to the numbers themselves, but to their placement. Making sure that we understand which one is the initial, what does that do? Which one is the multiplier, what does that do? And which term number are they asking you for? By the time you get to something like letter C, the term number is going to get a little more interesting. So I'll do one more example with letter C so you can start to get the idea, and then I'll have you try to do some of these independently on your own. Again, paying attention to structure in letter C, the initial value, always the number before the parentheses. The multiplier, always the number inside the parentheses attached to the exponent. And the exponent itself is always the term number. So looking at this one, analyzing its structure, I see an initial value of 6, a multiplier of 1/2, and they're asking me about the negative second term. So the reason I want to think about all of those things right off the bat is so when I make my table, I have a sense of direction here. They always will give me the initial value, so they're always giving me the 0 term. In this case, they're telling me that the 0 term is 6. But now, I'm not going to go forward in the table and waste my time. I'm going to say to myself, hey, wait a minute, 6. Okay, but they want the negative second term? Let me build my table backwards to get to the negative second term. The multiplier tells us how to go forwards in the table. So the multiplier of 1/2 tells me that half of 6 would be 3, but forwards in the table is how the multiplier applies. If I want to go backwards to get to the term in question, because remember I want to get to the negative second term here, that's my goal, then I need to adapt this a little bit. If the multiplier is normally multiplying by 1/2 or dividing by 2, then to go backwards I need to be multiplying by 2. Kind of makes sense. It's the reciprocal. You could think of it that way. It's reciprocating because you're going backwards or reverse. So 12 must make sense for the negative first term because 12 divided by 2 would be 6. 6 divided by 2 would be 3. There's my multiplier working. That's exactly what we thought. And if we go backwards one more time and ask ourselves, well, what would have been the term before the 12? Well, 24 seems to make sense because 24 divided by 2 would be 12. 12 divided by 2 would be 6. 6 divided by 2 would be 3. And the multiplier would be doing its job just the way it's normally supposed to do. So I can infer then that the value of this expression must be 24. The value of the expression really just means what is the value of the term number that they specify. If they specified term -2, they're really asking what's in that spot in the table where the -2 would fall. So as you're doing these problems, consider having some sort of table on scratch paper that you can use to help. If you have another way of doing these problems, that's completely fine. But please try to do it whichever way you're going to use without a calculator. The reason for that is so that we can really start to better understand what's going on and why, because that's an important connection we're going to make in the next section. So between now and the time you start the next video, really look at question number 3. Make sure that you understand what's going on and why it's happening in whatever way makes sense to you, so that when you get to the next section, you'll have an idea of why we're going to do things the way we will.